Today, we are exploring the fascinating story of a rather mysterious element, beryllium. It's the fourth element on the periodic table. You might not have heard of it, but this remarkable metal is the silent hero behind everything from life-saving medical scans to humanity's deepest look into the cosmos. It is light, it is incredibly stiff, and it has a unique relationship with radiation. However, there is a twist. Beryllium has a dark side. It is highly toxic and must be handled with extreme care. So, let's dive into the world of this paradoxical element. First, how does beryllium help in the medical field? Interestingly, it is rarely used inside the body, but it is essential in the machines that see inside us. Because beryllium atoms are so small, the metal is almost transparent to X-rays. This makes it the perfect window in X-ray tubes and mammography machines, allowing for sharper images at lower radiation doses. It also appears in powerful alloys. Beryllium copper is strong, non-magnetic, and non-sparking, making it ideal for surgical tools and for components inside MRI machines, where magnetism would be a disaster. But beryllium's superpower truly shines when we look at energy. In nuclear reactors, it acts as a neutron manager. It reflects stray neutrons back into the core to keep the reaction going. It slows fast neutrons down to the right speed. And remarkably, it can even act as a multiplier. When a high-energy neutron strikes a beryllium atom, the atom can sometimes release 2 neutrons. For every 1 neutron that goes in, 2 come out, amplifying the chain reaction. Now, despite these high-tech uses, you might wonder if you've seen beryllium before. The answer is almost certainly no. While it occurs naturally in certain minerals, the pure metal itself is toxic. The danger is not in touching a solid block, but in inhaling its dust. Grinding or polishing beryllium creates a fine dust that, if inhaled, can cause a fatal and incurable lung disease called chronic beryllium disease. This is why its use is strictly controlled in industrial settings. So, is beryllium itself a crystal? In a scientific sense, yes. As a pure metal, its atoms are arranged in a hexagonal crystal structure, making it a crystalline solid, even if it looks like a simple gray metal to the naked eye. This brings us to perhaps its most glamorous role, as an aerospace metal. Beryllium is what propels our vision into the cosmos. The James Webb Space Telescope's iconic gold mirrors are actually made of beryllium, coated with a microscopic layer of gold. Why? Because beryllium is unbelievably stiff for its weight, allowing for a massive mirror that is light enough to launch. It also remains perfectly stable in the extreme cold of space, expanding and contracting so little that it holds its shape perfectly, allowing us to see the earliest galaxies. But its functions don't stop there. Beryllium oxide, a ceramic form of the metal, is a thermal management superstar. It pulls heat away from high-speed electronics while acting as an electrical insulator, keeping powerful radar systems and supercomputers from melting down. In the world of high-end audio, it is used in speaker tweeters because it is light enough to vibrate incredibly fast and stiff enough to never distort, producing pure, clear sound. And in beryllium copper springs, it provides a mechanical memory, flexing millions of times without ever wearing out. So, what is the final summary? Beryllium's benefits all stem from a rare combination of properties. It is lighter than aluminum, but stiffer than steel. It is transparent to radiation, yet incredibly strong. It conducts heat like a metal, but can act as an electrical insulator. It is the material engineers turn to when the limits of physics, whether speed, heat, or weight, are being pushed. Whether it's seeing inside the human body, managing the heart of a nuclear reactor, or looking back to the beginning of time, beryllium is the silent, rigid, and stable platform that makes the impossible possible.